Hello, my name is Rodrigo. I'm doing my PhD at the University of Campinas under the supervision of Professor Nelson Fonseca. I will present an overview of my thesis. My thesis is about the fog nodes location problem, and this thesis is part of the Big Cloud project. So I will start presenting some motivation to this problem and then stating the problem itself, showing some solutions, results, and also future steps in this research. According to Cisco, the number of devices is increasing. So by 2023, there will be almost 30 billion devices connected to the internet, including PCs, smartphones, sensors, and other devices. We see here that this increase seems to be linear, but the increase in traffic by mobile devices looks exponential. So, according to Cisco, by 2022, there will be a sevenfold increase between the traffic uh, by mobile devices compared to 2017. And this is a problem because our current networks may not be able to transmit such a big traffic. So these devices, many of these devices are resource limited, like small sensors that gather data from the environment and send to the cloud for processing. But these devices will be running low latency applications. So in the traditional model, we have a device that connects to the cloud to send some processing and then receives the results back using the internet. But in this case, we have a very high delay imposed by the networks between the cloud and the user. So, with the employment of fog computing, this device can offload um, the workloads to a nearby fog node, and in this case, we will have a very low latency, allowing some real-time applications, near real-time applications. So the problem in my thesis is to decide the locations to be used by fog nodes. So this is a variation of the facility location problem, a problem that must be solved by the infrastructure provider, a network design problem, and the input is a set of candidate locations, and the output a subset of this set with the locations for fog nodes. This is an optimization problem, and it may have multiple goals leading to possible multiple solutions. So, for example, suppose we have some positions here where we can deploy some fog nodes. The solution of this problem would be the locations where we put some fog nodes to serve these users um, in different locations. Given that this problem is an optimization problem, we modeled it using linear programming. And to make it realistic, we modeled the time variable demands considering several locations with different demands. But although the end users are mobile, usually this infrastructure is fixed. So once we deploy it, we cannot change. And that's why it's very important to decide on this location properly. We use it as solver to obtain results, but for some scenarios, the number of variables and constraints is very high, so we also proposed some heuristic algorithm for these cases. And the results we have so far shows that even when we reduce the available budget, so we cannot cover all the locations, we can still do a good infrastructure to serve most of the users, most of the mobile users. And we also showed that we can do this fog node decision, location decision, in order to reduce the energy spent by these end users. And with that, users can stay more time connected to the infrastructure and using other services. So, if you are interested in a more deep explanation and details about these solutions, I invite you to check our last published papers. And in this moment, at the moment, I'm working on an idea of using a mobile infrastructure using drones. So, for example, maybe in the morning a fog node is very crowded and it needs some extra processing, and the drone can come, process the extra requests, and then later it can go to a different fog node. So we can consider not only mobile users but also mobile infrastructure in addition to the fixed infrastructure. And if you have any further question, you can contact me. Or if you want to learn more about the Big Cloud project, you can check the website. Thank you very much.